Imagine what someone who has been a project manager for a huge company of thousands of engineers crosses paths with a ragtag bunch of volunteers. And this is what Charlene has had to put up with us. And she's been very gracious. She's alerted us to the fact that there is a segment within the engineering community that deals with water that's very interested in green infrastructure. And she's assembled a panel to tell us about it. So thank you.
Thank you, Philip. And they're very easy to put up with because they're wonderful human beings, as you see, and really come from the heart here.
Just 1 minute.
Thank you. Okay, so I'm Charlene Johnston, and I'm a professional engineer, civil engineer, and my background is in water resources. Oops, I'm just going to move this gently, if I can get those out. Thank you. All right, great. So I have 20 years experience in water resources. It's spanned between municipalities, state, federal government, water, wastewater, to stormwater, to floodplains. And my stormwater experience morphed about 15 years ago into green infrastructure. And that's a wonderful thing, but I didn't realize how wonderful it was at the time, okay? So I'll go back in time a little bit just to set the stage for why I'm here with this group, and believe very passionately that this is the place for my energies to go for the environment and for the climate change, as you guys do. So in 1995, I was a young, impressionable student, and I was doing a paper for English class, and I chose it was going to be about climate change, but at the time we called it global warming, right? Before it got changed for terminology that was more comfortable to politicians. So with with global warming, the research I started to do wasn't related to my classwork. It's just something that clicked for me. And I went and looked at the congressional hearings that had, the testimonies that had gone on. And when I looked at those, I came out of there going, oh my God, what is happening? The world is falling apart. I alerted all my friends, my family, everything, that that's where I was going to put my energies. And I got an internship at IBM and got to work on the ozone hole, and it just looked like that's the way things were going. But then all of a sudden, someone put the brakes on and didn't tell me. I couldn't find a job in that field after I got out of college, and so I ended up a wastewater engineer, as I had been warned by a friend I was going to become, since I was in civil engineering. And next, though, let's leapfrog now, 15 years later, more than 15 years later. It's 2015, and I come across this wonderful group. And not in DC, though. I saw an announcement through the Chesapeake Bay Foundation. And it was the email that was saying, hey, we have a conference in Boston, and it's going to be at Tufts, and all these great speakers are going to be there, da, da, da. And I couldn't make it. Because my partner, Dan, who you're going to hear from, his son was graduating that weekend, so I was kind of previously committed. So instead, I got a chance to read Michael Kravchuk's report. And when I got in there and I read that, I just had such aha moments. And I went, oh my gosh, all this time I've been doing climate change work and I didn't even know it as a water resource engineer. And I was ecstatic. And so that's why I got involved here. And so what I heard through Jim and Adam and others, but today has been, to talk about the small water cycle. In water resource engineering, we do talk about the water cycle. We don't, delineate between large and small, but we talk about the water budget. And in our design work, we're looking at the water budget. And so that's just saying, if it's a mass balance equation, what are the inputs and what are the outputs? Well, we worried about that from, cost, efficiency of space, and moving the water out of dangerous areas for people initially. And that has, the paradigm shift has happened. It took a long time. When I was working on green infrastructure and Dan was 15 years ago, it was the new thing, the newbie on the block, okay? And so we were kind of the early adopters of that. What I see happening now is we need to be the early adopters of bringing this small water cycle into play in a way that we realize and recognize that soils and plants and the microorganisms in the soils are just as important to our design work. And we have started to do that at a different level in the engineering world, which I'm happy to be able to say. But it still hasn't quite clicked there yet. So it's happening, but we need to move the needle a little bit more quickly, of course. So what I'm hoping to do, and we've had some of our own crowd, if you will, come in the past hours, and they've gotten their feet wet on it. So hopefully that'll start moving out in our sector as well. So now to this, I've set the stage, but we have some distinguished panelists with us today, some dear friends and a new one. So as you heard, Dan's actually my partner. Dan Medina is a professional engineer. He has his PhD from Cornell University. He's a senior engineer with Limnotech here in DC. And he specializes in water resources, as you heard already. But he's also done projects, unlike me, where I've focused on North America. He's done them internationally as well, in Latin America and Europe and Middle East. So he has a different viewpoint. And I had the honor of working with Dan before we became partners in his role as an editor for the Manual of Practice for Design of Urban Stormwater Controls. And Dan will be our first speaker. And then we have Emily Landis, who is a, get this right, wetland strategy manager for Global Marine for the Nature Conservancy. And Emily has a master's degree in biology from University College London, holds a BA in environmental science and international policy from American University. Her role at the Nature Conservancy is to look at how coastal wetlands play in sequestering carbon and climate adaptation. She's worked for the Global Ocean Commission and the Pew Charitable Trusts. And I've met Emily by association because she was highly recommended to me by someone I know, the Director of Science at the Nature Conservancy. So we're honored. Thank you, Emily. Claudio Ternieden from Water Environment Federation. Now, the Water Environment Federation has 33,000 members, and it covers, it's an association for our sector of water professionals. And so it's, I think, going to be very useful in helping us move this discussion in a way that gets to our industry. And he has his JD from Pace University of Law in New York, a master's degree in public policy from George Mason University. And he's responsible for WEF's legislative and regulatory efforts in DC. And he's previously worked for WRF, which is Water, Environment, and Reuse Foundation, and the EPA. So I'm going to turn this over to Dan, and then our format is going to be each of our speakers are going to speak for about 6 to 7 minutes, and then I'm going to give them some questions that we've taken ahead of time, and then open it up to the audience for questions.
Good, thank you, Charlene. I need to get rigged up here, right? So, good afternoon. My name is Dan Medina. I'm a recovering engineer. Thank you. So, as Charlene indicated, I'm a civil engineer, and ever since I got involved with green infrastructure, I realized that we engineers don't know everything like we pretended to do for the past 200 years. And I realized that my work is a lot easier if I talk to soil scientists, horticulturists, landscape architects, the general public, kids. I mean, it really, oh yeah, that's right. Actually, lawyers are very important. Yes, thank you for reminding me. That's that's true. But anyway, this is what got me really excited about this because it's really cool. But then, as I got into it, I realized that old is new and new is old. So what Adam introduced and what I'm going to show you here is really an old concept. You can find it in Plato's the Dialogue of Critias about how we need to manage rain better because otherwise we lose our land to it. And you can go further back into Native Americans as we were discussing with my new friend Charito here. So I'm starting with that and I'm going to end with that. But the question here is, I'm supposed to represent here the small water cycle that Adam so ably introduced and the role of cities. I work in cities. And the question is, we need to hook this up, right? Yeah, oh, no worry. No? Okay, good. All right. So the question is, why do we need to worry about cities? You heard about farms earlier in the day, and you know that farms occupy a large extension of land. Cities occupy about 2% of the land mass around the world. And if you compare with what is considered potential agricultural land, that's more like 36% or so. So why do we worry about 2% of the globe if we're going to implement these practices? And I'll get to that. But this map shows you the biggest urban areas in the world. There's probably about 75,000 urban centers in the world, and the trend is for megacities. You know, we used to have about 5 in 1975. It grew to 15 in 1995. In 2015, we had 26 megacities, meaning places where people, more than 10 million people live. And you can see them here in my hometown of Bogota, Colombia. This is scheduled to become one pretty soon. And Claudio, you're not from Rio, right? You're from Sao Paulo? From Brasilia. Okay, well, that one is not there, but you know, you see Rio de Janeiro is another one. And you can see the big blob over there near in India and in Pakistan. And those are huge population centers. So even though cities don't occupy a lot of land, they wield a lot of power. In the developing world, 65 to 80% of the GDP of a country comes from cities. All right, a lot of decisions are made in the countryside because of what happens in a city. So even though the extension is not great, you still have to consider these things. Having said that, though, there's some pretty big cities. Tokyo, Osaka, it's about 12,000 square miles. New York City is 13,000 square miles when you look at the metropolitan area. Our own DC is 6,000 square miles, right? So I mean, just think about it. One of the examples of ecological restoration was in the Les Plateau in China. That was 6,000 miles, 6,000 square miles. So some of these urban centers, if you start dreaming big, you could restore all these urban lands, which are, for most purposes, wastelands, and you end up getting some pretty cool projects, and that will help what we've been discussing all day long. So this is why cities are part of the equation here. Also, cities have tentacles, right? London gets its tea from India, gets its copper from Zambia, gets its wheat from Kansas. So it's not just the city, it's where they reach and the influence. I wrote to the Science March, not the Science March, to the Climate March yesterday with a fellow I just met who works for the American Farm Trust. And we're having this discussion about urban environments and rural environments. And he said, look, we deliver what you guys asked us to deliver. You wanted cheap protein? We gave you cheap protein, right? And you can demand something else and we'll produce it. So when we have this kind of flexibility, this privilege, because we have disposable income in cities, when we have our money to make a decision, we should use it, just like we heard earlier, right? Because we do have the power to make that happen. So anyway, moving on. This is what happens to what Adam described in the previous discussion. This is, in very simple terms, the natural water balance. And it's kind of simple, right? You got your rain, falls on plants, a lot of it goes in the ground, very little goes as runoff, and a lot of it goes back into the atmosphere as evapotranspiration. Now we put a city, and to complicate things further, when you put a city, yeah, you get the precipitation, but now we're also importing a lot of water. Just think of LA. All the water in LA comes from Northern California, right? So you get this huge arrow here coming into the city, and then it also goes out as a wastewater discharge, right? Unutilized. And you see how the reduced evapotranspiration is signified there by the smaller arrow, which is what we described earlier as being part of the problem. We don't get enough moisture up in the atmosphere, and that causes a lot of problems, as we saw. Just to give you an idea, if another perspective on the power of nature for evapotranspiration. The typical quarter inch of water that evapotranspires in any given day is equivalent to about 6 tons of dynamite per acre. So imagine you have a 100-acre farm, and in each of those acres, 6 tons of dynamite go off every day. That's the power of nature in moving all that energy into the atmosphere. So what happens, what we're trying to do here as engineers is we're trying to create a different paradigm, just to use the word that is so commonly used now. But this is what we're trying to do in Australia. This is an Australian publication by Wong and Hoban. In Australia, they call it water-sensitive urban design. In the U.S., we call it LID, low-impact development. We call it green infrastructure for stormwater management. But it's about the same, except that I like the Australian take because it also includes wastewater, not just stormwater. And this is, you can see in the diagram, what they want to do, what we want to do is really to take some of that water that comes into the city and use it, put it to good use. It's been treated by a wastewater treatment plant. You paid a lot of money to get that water clean. Why don't we reuse it, right? That's going to reduce the demand. It's going to keep the water in the urban cycle, and we can put it back in the atmosphere. Now look at the arrow that goes back up in the atmosphere as evapotranspiration. We want to put this water where plants can do their work. When those 6 tons of dynamite can be put to good use to put it back in the atmosphere. So that's what we're trying to do. And whatever we have to dispose of, we want it to be clean, right? So part of what we do in green infrastructure in engineering is to control the water, but also if we have to let it go, it has to be reasonably clean. Now, unfortunately, we love our turf. This is just some numbers on turf in urban areas particularly. There are 40 million acres of turf in the United States. That's 2% of the land, all right? That's 4 times more than corn. And you saw that slide of how deep the roots are for turf. Nothing, right? But we just love our turf. You know, it's the largest irrigated crop. So here's the connection with water. You know, we're wasting water irrigating these things. Go to California. That changed because of the drought. But it used to be you have these lush green lawns. You still have golf courses in New Mexico where they don't belong, right? So we're putting 60 million acre feet per year of water. That means an acre foot is an area 1 acre, 1 foot deep, right? And that's 4 times more than hay, you know, which at least you can feed to cows, right? And is as much as the 7 largest water using crops combined, right? This is turf. Turf is the largest crop in the Chesapeake Bay watershed, right? So continue with water. Just watering your lawn, that's 50 to 75% of a home's water use during the summertime. That's a lot of water, right? And in most states, that's the largest crop to irrigate. So cities have the behavior that I described, but we also don't use our water very wisely, right? I mean, this is a precious commodity, and we put it in the ground. So in cities, we need to manage our water. We have a role in managing that water better. Now, so green infrastructure, what it does is essentially we green out of cities. So this is from Philadelphia Water Department, and you get the typical very highly urbanized, ultra-urban area, which is pretty much devoid of any green area. What we're trying to do is install these little dimples of the ground here, which have that infiltration capacity, where the water runs from the street into those depressions, and it sinks into the soil, becomes groundwater supposed to runoff. Here we do it with trees. You know, we have these tree trenches. This is a gravel material. When it rains, the water goes into that trench. It feeds the trees. The trees put it back in the atmosphere, right? And this is in a pretty tight area here. I mean, you look at it, it's pretty crowded. So there are very creative ways to do this at a very small scale all over the city, right? So the idea is to green our cities with green infrastructure that helps us with this small water cycle that we were talking about earlier. So what are these things? What are the techniques that we use? Well, we saw one in the lobby. It's a live wall, which I'm showing here. It captures, when it rains, it captures the water, right? But unfortunately, this one is indoors, so it's not going to capture any water. But when you build one, this is what they do. Green roofs. We could have a whole green roof as well, capturing the water, putting it back in the ground. I described the tree trenchers. Bioretention filters, you can do this in your home. And somebody already talked about the program in Montgomery County to do that. A bioretention filter is another. Where we use in engineering for rain gardens. But again, the purpose is to put the water back in the ground. Or you could, for example, use techniques that Emily's going to describe, like constructed wetlands, for example, or swales. Instead of using pipes, we could put the water in these shallow channels and put these dams that we saw in the photographs by Michael Krapsich, where the water gets detained and has time to infiltrate into the ground. So there's a lot of very creative techniques to make this happen in a city as part of what we do. Or you could drink it, which is what the Australians have to do because it's very dry there. You could have a cistern. And here they're called rain barrels. But the idea is to capture the water and use it for beneficial uses. So all is new is old, because these are all concepts, right? As I started the presentation, and I like you to indulge me a little bit as a proud father, but this is my daughter, who was speaking. Thank you. She was speaking at the pre-climate march gathering of indigenous peoples. Her mother's Native American, and she's right there behind her. And this is what she had to say.
Us young people are not going to back down because we know that we have a bright future. And I know that these next 4 years, they're going to jeopardize that bright future of mine. And it's going to be really, really hard. But I'm going to keep fighting. Because 20, 30, 40 years from now, I want to be able to go to that same spot and feel that same tall grass rubbing against my legs, and that same breeze blowing through my hair, and that same beautiful, fresh, sacred water. My name is Jansigwe, beautiful river woman, and I will not let anyone, under any circumstances, take away my connection, my river, my freedom, my name.
Thank you. Thank you. So I like to end. Thank you very much. Of course, I'm very proud of my daughter, but I like to end because this is it's an ancient concept. In the Lakota language, she's not Lakota, but we know some of that language. The expression is mitakyo yasin, means we're all related, right? And it's an ancient concept, and many people have crystallized it. John Muir said, whenever you try to pick one single thing apart, you realize that it's hitched to everything else in the universe. And that's what we're trying to do here. We can't separate the cities from the countryside. We can't separate water from soils. We can't use the reductionist theory of looking at only this thing and only if it has data. We have to look at everything together. So thank you very much.
Emily, thank you very much. While we get Emily fitted up for this, I'll just say Dan slid that in without me knowing. He had a 5-slide limit, but clearly it was worthwhile. So
So I'm going to turn this a bit salty. We've done a lot of fresh, so just going to let you know I'm done being fresh now. So what I'm here to talk about is blue carbon. Yeah, everybody? Thank you. Okay, cool. We have some people who know what blue carbon is. I don't always have that, so that's exciting. So what is blue carbon? So blue carbon is mangrove, seagrass, and salt marshes. We describe these as blue carbon systems because of their long-term sequestration and storage of carbon along the coastline. What is not blue carbon, and I have to say this just to be upfront, it is not coral reefs and it's not bivalve systems. They actually are carbon sources. We're not saying get rid of them. We need them, but they actually aren't helping climate mitigation. Not kelp forests and not fish, just because they do not have the long-term sequestration and storage the same way as the coastal wetlands. So that was just a quick overview. I'm happy to talk about it later if you have questions. And so what is coastal blue carbon? So what it is the CO2 from the atmosphere, and I can't go too far, is sequestered in the woody biomass of the mangroves or in the seagrass and the salt marshes of the plants. And there is some natural respiration and some decomposition, but given the actual salty nature of this area, there's very limited methane emissions. And so actually a lot of the carbon is piled down and it accumulates over thousands and thousands of years. So you can have 1 hectare of seagrass that has 10,000 years of carbon in it. So it's a pretty significant carbon sink, and it's very mildly touched most of the time because these are located in inlets, so they're not quite affected by the same soil and storm turbidity that comes in other systems. And then they're also, when they're degraded or lost, completely converted, they actually are a huge source of CO2, and I'll explain that in a second. Some of the biggest drivers of coastal wetland conversion is aquaculture. So I'm sorry to say to anybody who likes shrimp is not really great. Shrimp aquaculture is one of the leading causes. Second to that is rice. So rice also is significantly contributing to the loss of especially mangroves. Publication just came out 2 weeks ago that said eating a shrimp cocktail is the equivalent of eating an entire cow. So when you think about it it's a pretty big issue. So what do I mean by it's a big issue? So how important is it to climate mitigation? So on the left, and I'm sorry if anybody here is forest, I'm not saying you guys aren't important, but per hectare, mangroves, tidal marshes, and salt marshes sequester double than tropical rainforests, boreal forests, and temperate forests. So the beautiful coastal wetlands we have just a few 100 miles from here is actually more productive per hectare than the tropical rainforests in Brazil. So it's a pretty amazing stat to remember. We have our own carbon sinks in this country that are just as productive as tropical rainforests. And they're also being lost at probably a larger rate than most forests in the world. Currently, conversion of coastal wetlands is equal to the emissions of the UK each year. So it's a pretty high, so if we were to just stop tomorrow losing coastal wetlands, we would sequester all the carbon the UK emits every year. So it's a pretty big amount. And it's all about the co-benefits. And I know that this is an infrastructure, so I wanted to show and put up here coastal wetland protection during Hurricane Sandy. So what you'll see here is the difference in losses. So where there were pristine or functioning coastal wetlands, we saw a significant loss change from having those pristine coastal wetlands. So these are just amazing coastal barriers, and they're preserving hundreds and hundreds of millions of dollars as a green infrastructure. So it's extremely important to remember that these are the first line of defense in both storm surges and also in climate adaptation. It's important. These systems, coastal wetlands, actually continue to build up because they're taking ex situ carbon from upstream. So it is actually good to have some runoff because we do need runoff for the coastal wetlands or we'd be starved. So the ex situ carbon helps actually build up the soil so it keeps pace with moderate sea level rise. So coastal wetlands can be that first line of defense as the sea level rises. It's also important for fisheries. 95% of all commercial fisheries come from coastal wetlands at some point in their life cycle. Clean water, they reduce nitrogen passing through the open waters, and a big source of tourism, fly fishing. In the mangroves, a lot of primates live there, and so it's got a lot going for it.
What was losses of what?
Of
Difference in losses of what?
It was looking at both from housing, so it was looking at the housing. Yeah, the costs. Yeah. Sorry, and yeah, it's the publications there, which will go in a little bit more detail, which it was a Lloyd's paper, and it's Narwin et al. From 2016. So it's a very interesting read.
So, like a red area means what? Greater loss?
Less loss. So
I'm sorry. I was asking about it's a difference in losses of what, and you said it's financial losses. So could you explain like a red area means what?
means that where there was pristine wetlands, the red means there was less loss than in areas where there were. So 5 to 10. I really wish I could speak to this slide better. This is my fault. So my coworker did this one. So basically it's saying that the percent change in flood damages, so this is the flood damages to the housing, and so it actually was in like dollars. So where there was pristine coastal wetlands, there was less flood damaging. And so the difference in the losses, had there not been pristine coastal wetlands, would have been 100% difference. So looking at this area in Maryland, had there not been pristine coastal wetlands, we would have seen a difference in loss by almost 100% or 50 to 100%. So that's what it's more meaning. So that Hurricane Sandy could have been a lot worse had there not been coastal wetlands protecting. Yeah. And so the Nature Conservancy, recognizing that this is really important, hired me to lead the global strategy on coastal wetlands. So what we're trying to do is cut the annual coastal wetland loss in half, which reduces emissions by 0.23 gigatons of CO2 a year, and then also restore half of the coastal wetlands to their 1990 extent, which increases annual carbon sequestration by 80 million tons of CO2 a year. And we're doing this through 3 different approaches. So first, it's new science, building out more of the science to show what coastal wetlands do, communicate it, so coming to places like this and just educating people on the value of coastal wetlands, integrating best practices on the ground. So currently, I'm working in Indonesia, Papua New Guinea. We've got some states. We've got New Jersey, Florida, and a few other states starting to think about coastal wetlands and climate mitigation. And Mexico and Australia. And then we also are scaling, Maryland doesn't actually have any blue carbon work particularly, but they have in, I think it was the 2008 climate change announcement by the governor, he did cite coastal wetlands as a climate mitigation and adaptation benefit. So that's, but in terms of actual restoration or conservation because of climate mitigation, I have not seen that happen in Maryland. And then also working at the international level. So I've gone to the last 3 COPs for the UNFCCC and just trying to get blue carbon incorporated into country accounting of their coastal wetlands. So currently, if you lose a coastal wetland, the countries don't have to report on it, because there's no methodology and no requirement. So we're not even accounting for the land use, land change for coastal wetlands when they're being lost. So how do we get countries to start recognizing that value and actually putting it into their climate change accounting to the IPCC? So that's one level. And then also looking at nationally determined contributions to get to the 2-degree Paris Agreement target. And what we're finding is coastal wetlands in some of these, especially coastal nations and small island developing states, coastal wetlands is a really important asset that they should be using and using for carbon markets and financing to reach that 2-degree target.
Can you build coastal wetland out of nowhere?
No. I personally would never support doing that, because what you might be, we don't know what system was there before, so you might be introducing invasive species. You want to keep whatever system was there naturally, and so no afforestation. But it's very easy to restore some coastal wetlands. A lot of the issues, especially with mangroves, is you're basically starving off the hydrology, and it's usually dams upstream. So if you remove a dam, a lot of times the mangroves will come back, because mangroves are seen as invasive in many parts of the world. I mean, they can grow back like weeds. And we found this actually in Florida too, in Tampa Bay. The minute we changed the hydrological flows upstream, all the seagrass came back to Tampa Bay. So some of the restoration efforts are very small that need to be taken. It's just getting there. So that was it.
We're going to hang on to questions, okay? And we'll have Claudio come up, and then we'll take questions afterwards. Thank you so much, Emily. That was wonderful. And Claudio, what I neglected to say earlier in introducing him, he's the current Senior Director of Government Affairs and Strategic Partnerships for WEF. So that was Water Environment Federation.
No slides from me, so that's good. Thank you for the opportunity. I always enjoy speaking to folks. I consider it an honor when folks make time. especially on a Sunday afternoon. I said yes so fast, I think the email didn't move. So, because if you're here on a Sunday afternoon, it's because you really care. And care is really the key for a lot of what we need to be doing and what we do. I work for the Water Environment Federation. We represent 33,000 water professionals across the U.S. and internationally, close to 30 countries, maybe even more. Our members are, at the core, the operators that run wastewater treatment plants. They're the front line of treating wastewater and protecting our rivers and water bodies when it comes to cities and development, if you think about it. So one of the things that we as professionals in the wastewater sector, and then also the water sector broadly, have come to realize is that we have an army of partners out there. Folks like you, folks like Dan and Stormwater, environmental groups, in general, folks that care about water. What we never really thought much about is to work and to integrate some of that work that we do. So we are at the wastewater treatment plant or at the facilities that we run. We are moving levers and making sure it works and making sure that everything is doing what it's supposed to do, not thinking outside the fence too much. And over the years, we've come a long way to start thinking, I need to start thinking about how things get to my plant. Yes, we manage collection systems, so it's a new term for you. It's the wastewater system, it's the infrastructure in your cities, it's your pipes. For many, many years, especially in the East Coast.
Hello, you have been conducting a meeting for a long period of time.
Not really. We just started.
Press 1 now. If not, I'll end the meeting.
All right. Hey. So in the wastewater world, back to the pipes, what we do is convey things from your toilet to the wastewater treatment plant. The other thing that our members do is they take water from surface water and groundwater, they treat it, and then they send it back to you so you can use it. So that's the essence of who we are and what we do. We call ourselves utilities, water and wastewater utilities. We work with a broad group of people. We work with politicians. We work with the public. Why? Because we provide a product, we treat wastewater, and we provide you with a product. And we charge you a lot of money if you live in D.C., in other states as well, but in D.C. it's very expensive. Why? Because it costs a lot of money to do that and to do it well. But across the country, you all help fund the building of these infrastructures across the country in the different cities. We have a program under the Clean Water Act called the State Revolving Fund. Each state gets a pile of money through a Clean Water Act formula that says you have this much money to put into infrastructure. So they have to maintain those pipes. As you know, in Washington, D.C., you have old pipes, you have to maintain them. Why? Because if you don't, you're going to have problems with, in the drinking water side, getting good water. And I don't need to cite examples recently, you've heard about them. And in wastewater, you're going to have a problem too, because raw sewage will end up in your rivers. So it's very important that we invest in that. So a lot of the work that we do as utilities that manage these infrastructure is to make sure there are resources out there. Also, most of you contribute to the and the maintenance of these infrastructure through bonds, through rates that you pay. Municipal bonds constitute really the majority of the cost of the source of funding for paying for this infrastructure. So you all here, you might not have known that, but you all here help maintain the gray infrastructure that is the infrastructure of our cities. What's happening, though, and it has been happening for some time, and I think Dan does an amazing job showing green infrastructure as something that has grown in this group of folks that are focused in making sure that your wastewater is well treated and that you have good drinking water. In the middle of all this, and paying for all this, and thinking about safety, and thinking about public health, and the health of the environment, they also decided, well, maybe we can do things better. Maybe we can use green infrastructure sometimes instead of using great infrastructure, or instead of replacing with the same thing, let's think about how we can replace with something that works better. So green infrastructure over time made its way into the thinking of utilities in cities and how they think of themselves in urban areas. So we're seeing a tremendous increase of the use of green infrastructure. But it doesn't come, it does come with a price. But the price is not just money. The price is also that although we understand green infrastructure and we can measure, as you heard engineers measure things, they have great formulas for doing all this. There are a lot of uncertainties in green infrastructure. Would you agree with that, Dan? Yeah. So a pipe of a certain size, moving from A to B, you can count that, you can monitor that, and you can record that, and you can fix that. A green infrastructure is biology, it's nature. So although we understand it, it still does weird stuff. And we can't always control it or make it work the way we want it to work. Or it may need to be changed, or it may need to be maintained a certain way, or monitor it differently. So green infrastructure is not as certain in a lot of ways. It doesn't make it that we don't want to use it. We're still using it in a lot of our cities. But it's a different animal altogether. Different than what we've known for the entire time that we have cities and we've been managing infrastructure. So as we learn more and we increase certainty, we use them more. So I'm going to stop here and mention that the way all this is structured from a policy regulatory perspective is that we have the Clean Water Act, which is one silo, and you have the Safe Drinking Water Act, which is another silo. So the Clean Water Act is the one that came, that was passed after the river burned, if you remember. We decided that industrial waste led to really, really bad stuff in the river. We now needed to do something about it. Clean Water Act came through. It has an incredibly, incredibly complex process for managing and reporting and controlling these sources of industrial waste, and also putting requirements on municipalities on what they have to do, how they run the treatment plants, how they monitor the treatment plants, how they provide information to the public, how they deal with the public, how they fund it. All that is in the Clean Water Act for purposes of wastewater treatment plants. And the Safe Drinking Water Act then has a similar structure. They had learned some things from the Clean Water Act, so they put some things in there. For example, they're obligated to have trained and licensed drinking water operators. So the operators have a different way in which they get there. It's just to give you an idea. The way they monitor the chemicals, because it's drinking water chemicals, it's monitored differently. It's more intense, and as you would expect it to be. So these are the structures we have in place. Then there are statutes that deal with solid waste and deal with other things. And we all know that they exist. But in a water side of the world, you have that. Stormwater is under the Clean Water Act. You heard earlier somebody said CAFOs. Before the lunch, somebody mentioned CAFOs, Combined Animal Feeding Operations. So those are considered point source under the Clean Water Act. What that means, it triggers a whole slew of regulations and implementation procedures in how those farms are controlled. All these is because we are also concerned about source protection. So these are all terminologies that when you enter the water side of the world, there's a whole slew of language that we have. So just like I've been learning a lot of the language here, I wanted to put a lot of that language out there for you so that you understand that the structure that exists has been there for a long time. Now, with that, there is change coming. Infrastructure is one of the biggest ones. And one of the things that we are doing, because you asked me that I talk a little bit about what does that mean for folks locally and for how cities are dealing with implementation at the local level. So on the green infrastructure certification and green infrastructure side of things, because we don't understand it as well or need to learn more and need to educate better, we are setting up a national green infrastructure certification program that D.C. Water is actually part of it and one of the big supporters of that. And that is to create a cadre of professionals across the country that are trained in green infrastructure certification. Trained in green infrastructure, understand its elements, both for maintenance, monitoring, and installation. So that is one of the results of cities across the country recognizing, there are 16 of them right now, recognizing the importance of green infrastructure and how it needs to connect to the local population and with local folks that are interested in this. So that's just one of those projects that we have. We also have invested a lot as an organization in workforce development across the board, understanding that the utilities of the future are going to look different, because what we haven't talked about is reuse, right? So I specifically said drinking water and wastewater, but those two are starting to come together in something called reuse or recycling of water. So as we have less water in certain parts of California, Nevada, and areas with deserts, we are learning that we have to learn to take that water and use that water for other purposes. Not just, so reuse, not just for drinking water, which is different ways. There is indirect potable reuse, and there is direct potable reuse. One is you clean the water, you put it underground, it mixes up with groundwater, and then when you get it, it has like a ratio of like 100 to 1 or 200 to 1. Or direct potable reuse, which is it's wastewater that you treat and then you drink. We're not there yet in this country. Regulations and science and culture. I think that is good to understand that maybe the future. But for that to be the case, we have to understand the science, and it's not going to happen without working with folks like you over time. So I thought that a helpful role for me today here would be just to walk you a little bit through what the water sector is. And also there is this distinction too, because we talk a lot about agriculture. So you talk about the Chesapeake Bay, for example, how most of it, the utilities like DC and others have put expensive technologies in place to treat the nutrients and the phosphorus going into the bay. They've done a tremendous job. From that perspective, there's been a decrease in an influx of nutrients from point sources, that is cities and pipes, into the Chesapeake Bay. But then there is the agricultural side of things, and they're specifically exempted under the Clean Water Act. Let us sink there for a second. So we can't regulate them directly. Everything they do is voluntary. There are programs in the USDA, under the USDA, that fund set-asides and setbacks and other things, and they have been very helpful in getting farmers to do a lot of things. So I'm not saying the farmers are not doing their part. That's not what I'm saying. What I'm saying is the agriculture sector as a whole has benefited from certain exemptions that exist in the law. But they, as a sector, have done a lot. There are a tremendous amount of work being done by the agricultural sector. You work with them. But more needs to be done. So when you talk about budget cuts, because there is too much redundancy, and that's the argument we are hearing. Well, USDA and EPA both deal with the same topic. Well, no, not really. EPA is dealing with the regulated side of things. The USDA is dealing with the non-regulated side of things. They're not redundant. Those are two different things. So there's this idea that, well, we can cut this money. Yeah, we could cut the money from the farmers to the farmers. There is nothing happening on the farming side for dealing with problems that exist and we know exist. So there is a whole issue, because the Clean Water Act sets standards and says you have to meet water quality standards. But we already know that there are parts of the country, no matter if it was zero discharge from a wastewater treatment plant, that will still not meet the water quality standards, because the source of the problem is someplace else. And it's that integration between the requirements that we are having problems with. And that's the change that we should be looking for, not so much dismantling or erasing these regulations or doing away with those regulations 2 for 1. And that is using an axe to solve a problem that needs a scalpel. So from a structural perspective, the wastewater sector and the water sector stands ready to work in dialogue with folks and to continue to move forward protection of water in the United States, and to talk about stormwater and continue to implement green infrastructure and other things and best management practices. But at the same time, there has to be an understanding that we all have to work together, not just communities, but also the agricultural sector and other sectors. So that's a reality check in terms of where we are. At the same time, I'm excited to be in this sector, because it is a time, I think, that because of awareness, because of the ability to share information, we, I think, are learning faster, are integrating faster, and are communicating more and better with others. So I am excited to be in the water sector. I'm originally from Brazil, grew up there, and my parents were farmers. And they had a farm in Brazil and grew things. So being able to be in a country that has such civil society like you all on a Sunday afternoon here talking about this, that is tremendous and gives me hope. So I'm happy to be here, and thank you again for your time.